Hey everyone, and welcome to beautiful Bradenton, Florida. I'm here spending a little time with family, just enjoying the sunshine and kind of debriefing a little bit from 3 months out exploring kind of the Western Mediterranean, Club Med over there in Europe, Portugal, Spain, Sicily, Central Italy, Malta, and then France and Britain to finish things off. But yeah, this is kind of our beautiful scene out here, right next to Palmasola Bay. We're about an hour's drive south of Tampa. Um, but yeah, it's just interesting the contrast between all this plentiful water, everything's green, versus a place like Paris or certainly Sicily where it's just brown, no water. A few places are thriving, but generally, you're not seeing a ton of agriculture to speak of. Spain was doing much better in that respect. But yeah, throughout much of Southern Europe, it was just drought conditions like they haven't seen in decades. And then, right here in the U.S., we have, the Hurricane Florence situation, as well as the other storms that have been hitting Hawaii and are still inbound. And so there you just have a huge excess. I mean, trillions of gallons of water waiting to be dumped on the Carolinas. So, what does all this stuff mean? I mean, I've kind of built myself a bit of a professional rep and career around trying to use these lakes and seas of data to validate questions about how these different natural systems are impacting our human systems, whether it be financial markets or government, or just everybody in their day-to-day lives with their community, small businesses and families. So the interesting thing, this is the key takeaway that I've seen about hurricanes in respect to the United States, which is somewhat representative of the global economy. I mean, that's clearly changing, but what you see with hurricanes, if you look at the last century of data, is that whenever we see zero force 3, category 3 or higher hurricanes in a given year, years like say 1929, 1930, you look at that range of about 5 years, and there were very few powerful storms that made landfall in the U.S. Similar periods would be like 2002, 2003. So they're a fairly low occurrence event. I mean, usually we have, a handful of, category 3 through 5 storms make landfall in any given season. But those years that they don't happen to be right before or in the midst of some major financial turmoil. I mean, the one that happened in the late 20s, early 30s, that little drought literally was in the midst of the financial crisis and the Great Depression, right? And one of the other ones that happened in the early aughts was just after the tech crash in 9/11. And even though we were able to sort of ease and inflate our way out of that one, before you know it, we had another financial crisis, 2008. So it's an interesting question. Why is it that something that seems like a very destructive and negative event, like a powerful hurricane, say like a Hurricane Andrew, or Harvey that hit Houston, just did massive damage, 60 inches of rainfall in a very short period of time, so a huge amount of flooding, and yet you see Houston actually bounced right back from it, right? So it wasn't our Hurricane Katrina and New Orleans kind of disaster where there was actually a diaspora and a major migration of people away from Louisiana to other parts of the U.S. In Houston's case, they were actually prepared for it, and despite the damage, they saw quite a bit of new car buying, just kind of fixing things up, and it wasn't such a huge financial impact that it wiped out the risk industry, the insurers, right? Because the rest of the economy was actually firing on all cylinders. So, in kind of the right context, big storms can actually be somewhat of a stimulating event. And if we want to really get more into kind of the science end of things, another interesting data set discipline to look at is tidal science, right? So agencies like NOAA, National Oceanic and Atmospheric Agency, which is part of the U.S. Department of Commerce, measures all kinds of Earth systems. They've got satellites, they've got sonar buoys, they've got ships out in all the different major water bodies, just measuring everything about those systems. But if you just look at their tidal data sets for some of the major ports like New York, Los Angeles, Seattle, and so forth, you'll actually see, if you look at the extremes, which they've got going back, at least 100 years. I've studied the one for Seattle and Elliott Bay fairly extensively because that goes back to the late 1800s. So you have a huge data set there. It goes back almost as far as most Dow Jones index data sets, and so that's pretty useful because you can try and at least make some inferences based on extremes and if there's any cycles in there, which it does seem like there are. There's about a 17-year cycle that you see in the tidal gauges of major U.S. ports, and I don't know. There's no official name for it. I just call it basically the hydrological cycle, but it's got about the same length as the major reserve currency, which is the U.S. dollar right now. Although it does tend to lead a little bit, and it really comes down to just really basic macroeconomics. At least this is the theory, and how that works is basically when you have a large amount of water being carried into a basin. So all civilization ends up being based on agriculture, which is very water dependent. And when you have these settlements, these city-states and walled cities that end up growing up around typically the lower part, the drainage, the estuary of a river basin, that's how you get massive cities like New York, Shanghai, London, right? Is that they're a collection of towns that are first agricultural, but then they become more commercial and industrial, and they grow up around these. It's basically the drain of a giant bathtub, and so the more water being brought into that basin, first accumulating, as snowfall, rain, reservoirs now in major dam projects. That's money. In fact, one of the most consistent ways of one of the biggest, largest batteries in the Pacific Northwest U.S. at least is by using spare generation to lift water with mechanical pumps, right? So, some coal power plant or wind power plant is generating more than they can either market and sell, or, there's just not that consumer demand there. They just run it to a dam, and that dam uses pumps to pump up water, and that's saving potential energy, right? That water can be re-released either through the dam's generators or for other purposes, and that's got real economic value. So it acts as a giant battery. So that's just one application where volume of water and basically the altitude above sea level of that water are potential energy that can translate directly into economic and financial value. So basically how this works is that if you look at the major highs and lows of any given major port's tidal data set, you'll see that they hit these major highs, so they have very high water levels despite the fluctuations, from the moon, other factors. And so when you see basically a surplus of water flows into those areas directly adjacent to these ports, it's telling you that they're actually rich, right? There's a lot of volume, a lot of potential hydraulic energy that's traveling through that system, all the way from the dam projects at the top of the basin, all the way through all the agricultural activity that's going on, and then draining through all the other industrial uses for water, and then ultimately being dumped out into their bays and into their sewage and storm systems. So when you see these data sets start to fall and you see tidal levels making new lows, that tends to actually lead financial crises and economic recessions and depressions by just a few years. So that's basically a water deficit leads to an economic deficit, and it's physics at the end of the day, and yet it's got such a huge impact on our human systems. So that's just something for you guys to kind of chew on a little bit. That in many cases, even storms, because they bring a huge amount of potential energy in the form of water at altitude, can actually be a good thing. And when we see things like Florence or even Irene that came through Florida area last year, dropping from a potential category 4 or 5 down to a 2 before they actually make landfall or hit a major basin, that's exactly the same thing in application or an impact as a Facebook losing 20% after a bad earnings call, right? All that potential energy just basically got dissipated without resulting in rainfall. So that's something to consider, is that if the U.S. does end up having a hurricane season with no Category 3 or higher making landfall, that would be a major red flag. And also, the tidal data sets are already showing that there has been an effective shortage of water, because those data sets peaked back in like 2014, maybe early 2015, and we're actually starting to make new, below 50th percentile extreme lows in several of the major data sets. So that's telling us that, basically that economic pump, not Ray Dalio's, but more of the hydrological version, those economic pumps are starting to run dry. And it's something we're going to have to figure out, how to compensate for that loss of battery. So thank you guys for listening, and looking forward to our next chat.